equations. So the first step to solve differential equations is to separate the variables, everything with y on one side, everything with x on the other side. So we do that by multiplying or dividing both sides by the same thing. Here we multiply by dx over y minus 1 because on the left we cancel out, we have only 1 over y minus 1 dy. On the right we cancel out, we have only 1 over x plus 1 x plus 3 dx. So now we have to use the partial fractions because we can integrate the left hand side, no problem. Problem is when we integrate the right hand side, there's no MF19 formula for this. We have to use partial fractions decomposition first. So this is the partial fractions decomposition part. So for this form, x plus 1 x plus 3, we have to use something over x plus 1 plus something over x plus 3. We multiply both sides by the denominator. On the left they cancel out, we have only the numerator 1. On the right, when we multiply, we cancel out x plus 1, we have a times x plus 3, and when we multiply the second term, cancel out, we have b times x plus 1. So now we plug in the zeros of x plus 3 and x plus 1. We plug in minus 3 because when we plug in minus 3, this term goes to 0. We can find the b, so plug in minus 3 here, we have minus 2, which means the b is minus 1/2. And then we plug in minus 1 because that is the 0 of this term. When we plug in minus 1, we replace the x with minus 1, we have 2, replace the x with minus 1, they cancel out, we get 0. We can find the a, which is 1/2. So now we know the a and the b. We replace this a with 1/2 and this b with minus 1/2, just like this. And then we integrate now. We can integrate everything now. So for 1 over y minus 1, we use this rule. We get ln the denominator, so ln y minus 1. And for here, we rewrite the coefficient 1/2. And for the integral of 1 over x plus 1 is just ln x plus 1. Same thing here, we still have the coefficient. The integral is ln x plus 3. We use constant of integration on one side. Let's put it on the right. This is called the general solution of the differential equation. To find the particular solution, we plug in the y and the x value. So we replace the y and the x. This is ln 1, which is 0. This is ln 1, which is 0. This is ln 3. So the c is 1/2 ln 3. Now that we have the c, we have the particular solution. This is already the particular solution, but we need it in this form, y in terms of x. So we start by moving this 1/2 inside the argument of the logarithm. It becomes the power here. Same thing with the other 1/2, we put it here. So we have to the power of 1/2, to the power of 1/2, to the power of 1/2. To the power of 1/2 means square root, square root, square root. And then we can combine logarithms if it's subtraction or addition. Subtraction means we divide, addition means we multiply. So in short, if the term is positive, you put it above the division line. If it's positive, above the division line. If it's negative, it's below the division line. So we multiply 3 times x plus 1 is 3x plus 3. We combine the whole big square root here. And then we cancel out the ln. We do e to the power of both sides. We have only the argument y minus 1 and square root something here. And finally, we add 1 to both sides. We get y equals something in terms of x. Alright, I'll see you again next time.